All right, hello everyone. Today is epic. Today is like we are going to go so far down the rabbit hole of tangents and circles that you will just not want to live there forever. Okay, this is real red pill stuff. Okay, so we're going to dive right in. We're going to start easy, and then we're going to go hit some of these ones really hard. We're going to bombard these with maths. So tangents, we know about them already, and we know about circles. So this is where the marriage of coordinate geometry of the line and coordinate geometry of the circle, is consummated, for want of a better word. So let's dive in with some super easy ones. And once we've got the easy ones done, then we'll trick ourselves into doing the hardest ones. Here's a nice little simple one to start with. Okay, the equation of a tangent, we need to find it. All we have is the point of connection and the equation of the circle. Okay, so let's get cracking right to it. How are we going to do it? So we have one point. We know what the other point is because we can read it off the equation of the circle. The equation of that circle is the center of 0, 0. So we have 2 points now, 0 and 0 and 2 and 2. Okay, that's going to allow us, should we wish it, zooming out here using my very high-tech zoom out abilities. Okay, so this will allow us, if we should desire, to be able to find the slope of the point on the line that joins. So I'll be able to find this slope here. And then because we know this is a right angle, I can find this slope here by getting the inverse of it. Okay, so y2 minus y1 over x2 minus x1. That's 1. Slope of 1. Yeah? If it's a slope of 1, that means the inverse slope is minus 1. So that means the slope of this one is minus 1. So now we have a y minus y1 is equal to m on x minus x1, where m is minus 1 and the point is 2 for x1, y1. Okay, so let's put them all in. Y minus 2 is equal to minus 1 on x minus 2. Y minus 2 is equal to minus x plus 2. X plus y minus 4 equal to 0. There you have it. Okay. That's probably an ordinary level, top end of an ordinary level type of question. So we're not going to spend too much time on them. It was just a nice kind of mover in. Feel free to pause, rewind, try it again yourself. So let's kick it into a little bit harder. What we have here, we have a circle, x minus 1 to be squared, y plus 2 to be squared equal to 20. Verify that 3, 2 is on the circle. Write down the coordinates of the center of the circle and find the equation of the tangent at the point P. Okay, so 3 for the price of 1 here. Let's crack into this. So first of all, let's write down our circle. X minus 1 to be squared plus y plus 2 to be squared is equal to 20. Center of the circle, very easy. It's going to be 1 and minus 2. It's the opposite of what you see because it's in this short form. Okay, that's the first bit done. Let's verify that 3 and 2 are on it. Let's replace the x with 3, the y with 2, and see is it equal to 20. 3 minus 1 is 2. Okay, 2 squared is 4, and 16 is 20. That is true. So that's the first 2 bits done. Third bit, find the tangent. So we have a center, 1 and minus 2. We have a point, 3 and 2. Let's get the slope. y2 minus y1 over x2 minus x1. 4 over 2, which is 2, which means the perpendicular slope is minus a half. Let's park that. We're going to use that with that point. Y minus y1 is equal to m on x minus x1. Bottom left, top right. 2y plus 4 is equal to minus x plus 1. X plus 2y minus or plus 3 equals 0. Done and dusted. Again, probably an extremely hard higher or ordinary level question, or maybe a very easy higher level question, maybe part A of a higher level question, maybe only worth 5 or 10 marks. So there's your 2 kind of basic starters. There's your basic strategies if you want to go at it. Now let's kick it up a notch and we'll go into some of the more what I would consider challenging questions. Okay, so With these questions, something's missing, basically. That's what you're really dealing with here. So, and again, you have to use some of your strategies to kind of figure it out. So the first one I suppose we'll do is we'll do a nice easy one where they're kind of, you know, they are flagging what you have and what you need in a lot more kind of detail than maybe what you would have thought. So in this case, question 7, we have a perpendicular. Find the perpendicular distance from 0, 0 to the line 3x minus 4y minus 25 equal to 0, and hence show that that is a tangent to that. Okay, so the perpendicular, the perpendicular distance, well, we already know what the perpendicular distance is going to be from, I'll just write it all down here so we can have it, so you can see it. So we have a line 3x minus 4y minus 25 equals 0. And we have a circle, x squared plus y squared equal to 25. The first thing they ask you is to show that the perpendicular distance from 0, 0 to 3x minus 4y minus 25, the perpendicular distance is, show that it is 5. Okay, or no, they actually want you to find it, but you already know what it's going to be, because if you have a circle that has a center of 0, 0, then the radius of it, if they say it's 25 in the formula, the radius is 5. So they're just really asking you to prove that the perpendicular distance is 5. Okay, I'll do it in a second. What else are they asking you to do then? Well, then they want you to show that this is a tangent to that. Well, you know, if it's a 5 centimeter, it's a distance of 5 away. Yeah, you know, it's going to be. But that's anyway. Let's show that the perpendicular distance between there and there. Can you remember about perpendicular distance? What do we need? Okay, we need an x and we need a y. Okay, and then we need an a b, and a c. So it's going to be 3 times 0 minus 4 times 0 minus 25 all over the square root of 3 squared plus 4 plus minus 4 squared, which is going to be 5. So that's 5 over 0 minus 25. Remember, its absolute value, which is 5. Okay, so the perpendicular distance from 0, 0 to that line is 5. The radius of this circle is 5. Hence, they have to be tangents. It's as simple as that. Okay, so there's a nice little easy starter just to kind of get you into the swing of things. Yeah, we'll go for a bit. We'll go a little bit. We'll go a little bit tougher, I think, on the next one. Okay. So let's have a look at this one. This one's a bit tougher. So we have a circle. Okay. First of all, we'll get the line 2x plus ky minus 3 equal to 0 is a tangent. So it is a tangent to this line. X squared plus y squared plus 4x minus 4y minus 5 equal to 0. And I suppose the question they're asking is, if it's a tangent, can you find the possible values of k? Okay. So let's think about it for a second. Okay. There are a couple of different ways we can go at this. We can, I think the easiest way to go at this personally is to reverse the process with the previous one I did. We have everything we need to do a perpendicular distance apart from the center, which we can get from this, and the radius, which I can also get from this. So I think that's going to be my thing. How are we going to get the center? The center, when it's in this general form, is half the x value and change the sign. Okay. And then half the y value and change the sign. The radius is going to be the square root of minus 2 squared plus 2 squared. And now this is where you have to be super duper careful. It's minus whatever that is. So it's plus 5. So I don't know what that is. That's going to be 4 and 4 is 8. It's root 13 is the radius. Okay, so that's what we're going to have to put into our formula. Everything we know. So let's do our perpendicular formula. Okay, let's just label up everything we have. We have an x and a y, and we have an a b, and a c, and we have the answer. So we have everything we kind of need. Let's throw it all into our perpendicular formula. So the answer is root 13. I'm just going to throw it out there, and we're going to have square root of 2 squared plus minus k squared on the bottom here. So what we're going to do, it's going to be 2 times minus 2. So we've got 2 times minus 2 minus whatever this is, k, minus k times 2 minus 3. So that's going to give me whatever, minus 4 minus 2k minus 3. So we've got minus 4 minus 2k minus 3 all over the square root of 4 plus k squared equal to root 13. Okay, so remember we've done these ones before. You know, that can be tidied up a little bit, but we've done these ones before where we're just going to have to do the absolute value type of thing. So, you know, you can square both sides and then solve for quadratic, blah, 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 and you get 2 possibilities. So let's go crazy and let's do this one. So a bit more space here. So let's bring this up here and we'll see where we go with it. So let's multiply out this side of it first of all. This is root 13 by that. So let's get that to one side. So remember, we're going to have absolute value of minus 7 minus 2k equal to root 13 root 4 plus k squared. Okay, so there's a couple of things you can do here. You can multiply roots together by putting them under the one root. One root. That might just tidy things up a little bit for you. Minus 7 minus 2k equal to root 452 plus 13k squared. So at least that tidies that up. Now, you know what to do here. Absolute values, square both sides. So that's going to be whatever. Minus 7 minus 2k squared is equal to 52 plus 13k squared. Okay, let's tidy this up. Square the left, square the right, multiply them together. That's 14k and double it, that's 28k. Let's bring these over. Minus 52 minus 13k squared equal to 0. Let's tidy this up. What do we got? Minus 9k squared plus 28k. And then what do we left? Hit minus 3 equal to 0. Let's rearrange that and solve. That's 9k squared minus 28k plus 3. No, Jesus. Okay, use a minus b if you're not going to be happy with this. I'll try a 9k and a k. Will this work? 3. Okay, and 1 and a 27 and a minus and a minus. Have to be a minus and minus. So k is equal to 3 or k is equal to 1 over 9. I'm going to assume that that's right. Okay, there's the 2 possibilities that would make it work. Now that's a bit epic, that one. That one's definitely a bit epic. You know, so that's where we're getting into that, ooh, you know, where we're actually, look, there's a lot of work happening here. Okay, let's go deeper. Let's go deeper into this well of tangentials. So let's get crazy with some of this, okay? I'm trying to see now which one here is juicy. Find the center. Sorry, I'm just showing you here. Find the center of a circle C. You want to find the center circle C. Oh, find the equation of the circle C whose center is. Okay, all right, that's not too hard. So, listen, you can see what you have to do here. I'm not even going to bother doing this. You've got the equation of the line. You've got the center. You can work out the perpendicular distance. That give you the r value, the radius. Once you've got the radius and you've got the center, happy days. You know, x minus h, y minus k is equal to r squared. It's not exactly rocket science, that one. Okay, it's an easy one. Write down the equation of the line which contains the origin, okay, and whose slope is n. Hence, find the equations of the tangents from the origin to the circle. Okay, this one's a nicer one. Okay, question 13. Definitely a nice one. I can see a little bit of fun on this one. So let's have a look at it again. We have an equation of a line which contains the origin. So if the line contains the origin, that's a very particular type of line, okay? And whose slope is m. So 0 and 0 must be one of the points, x1, y1, and m is m. So we'll do that first of all. Y minus 0 is equal to m on x minus 0. Okay, so y is equal to mx, or mx minus y is equal to 0. So there's your some type of formula for the circle or the line. Right, so what do we need to do next? Hence find the equations of the tangents from the origin to the circle. Okay, so there's the way this is kind of, they're giving you a general formula for any line that goes through the center. Okay, and the way I'm visualizing it is something like this. Let's say this is the origin right here. They're imagining a scenario like this, and then the circle is kind of like stuck in between it, you know, so you get two possibilities and only two, you know, that type of way. So we have to kind of work out both of them. So that's what in my head, what we're kind of going for here. So let's have a think about it. Now we have a lot of information here because they're giving us a lot. Okay, so one of the things they're definitely giving us here is they've given us the full equation of the circle. So let's get that written down. We have x squared plus y squared minus 4x minus 2y plus 4 equals 0. So I mean, they've given you a lot of information here. So let's get the center of this circle. The center of the circle is half the x change the number, half the y change the number. Okay, so that's that done. That's easy enough. Let's find the radius of this. It's going to be the square root of, what is it going to be? Minus 2 squared plus minus 1 squared. And then this is always the one you have to remember. There's always a negative, and then throw in the c. So that's 4 plus 1 is 5. Square root of 1, which is 1. Radius is equal to 1. Okay, so that's pretty okay. So now we've got a lot of information about this, you know, hypothetical circle. Okay, we have a center of it, and we have the perpendicular distance. See where we're going here? Okay, so if we have the center and the perpendicular distance, and we have the equation of the other fella, then you've got a lot of information there to kind of build up the possibilities for m, if that makes sense to you, so that you could work out what it could be. Okay, so let's try and throw these into then our perpendicular distance. So what we got? We've got a 2 and a 1. Okay, we've got mx, whatever it is, minus y. Okay, and we know the answer, the distance has to be 1. So the distance equals 1. So let's throw them all in as much as we possibly can. Remember, that's going to be A and that's going to be B. Okay, and that's x and y. So absolute value of, what is it, m times 2. So that's 2m. And then what do we got? Minus 1 by minus 1 by 1 minus 1 minus 1. And there's no c, so that's easy enough. All over square root of m squared plus 1. Isn't it really? And that has to be equal to 1. Okay, so let's cross multiply here. So we've got 2m minus 1 equal to the square root of m squared plus 1. So listen, from this point, you can just, you know, do whatever you want in terms of that square on both sides. 2m minus 1 to be squared is equal to m squared plus 1. What's that going to be? 4m squared plus 1 minus 4m. Bring it over, minus m squared minus 1 equal to 0. That's going to be 4m squared. That's going to be 3m squared. Minus 4m equal to 0. M on 3m minus 4. So m is 0 or m is 4 over 3. So there's your two possible tangents. One of those tangents, let's do the two tangents now. This is our general formula for the tangent. If m is 0, then one of them is going to be y equal to 0. So the y or the x-axis. And then the other one, if m is 4 over 3, then you're going to have 4 over 3x minus y is the other possibility. Okay. It doesn't look nice, but it is what it is. Okay. You could draw them, but I'm not going to draw them. That's getting epic. That's getting cool. So we're definitely getting into the nice ones now, the ones that are going to kind of make you or break you. Right, so that was 13. 14 is basically the same. 15, write down equation of any line parallel to this. Not too hard. Hence, find the equations. Find the equation of the tangents. Okay. That was not too hard. Okay. If you look at this one, number 15, I don't know if I'll do it, but you know, write down the equation of any line parallel to 3x plus 4y minus c. It's going to be 3x plus 4y plus minus 6 plus c. So that's a general equation for anything that's parallel to this one. And then look, you know, they want you to find the particular tangents. Well, listen, you've got everything you need when you think about it. You can find the center, you can find the radius, which means now you can find the c possible values by putting it into your perpendicular, solving it the whole way down, you know, the usual, and getting an answer. Okay, I'm not going to bother because we've done a few of them similar enough to it. Center and touches, find the radius. If it has the center and it touches, you can find the perpendicular distance, find the equation. Yeah, listen, that's just rolling those previous ones in together. Ooh, 17. 17 looks juicy. Okay, looks like there's a bit of work here on 17, so let's have a look at it. So, question 17, we have a lovely little formula. We have an x squared plus y squared minus 10kx plus 6y plus 60 equal to 0. And the only information they tell you is that k is greater than 0. That would lead me to believe that there's more than one possible k, and you ignore the ones that are less than 0. And they also tell you that it has a radius of 7. Okay, interesting. And the first thing they want to do is find the center in terms of k. Well, the center in terms of k is going to be half the x coordinate and change the sign. So it's going to be 5k. Change the sign, minus 3. So there's the center in terms of k. Simple enough. Okay, find the value of k. Well, what do we know? Well, we know enough information because we know what the radius is. We know the radius is going to be, what is it going to be? Minus 5 k squared and plus 3 squared. And this is the important bit, minus 60. And the whole thing is equal to 7. Okay. So you can square both sides. Okay, that's going to be 25k squared plus 9 minus 60 is equal to 49. 25k squared is equal to 49 plus 60 minus 9 is 100. K squared is equal to 4. K is equal to plus or minus 2, but we're ignoring, remember, greater than 0. So the answer is k is 2. Okay, and then the next thing they want you to do here, the line 3x plus 4y plus d is a tangent to the circle where d is an element of the integers. Show that one value for d is 17 and find the other possible value. Okay, so let's try and put some magic on this. So let's rearrange. We now know that the center of this circle is 10 and minus 3, and we know the radius is 7. So we know that information, and we have a generic 3x plus 4y plus d equal to 0. And we want to show, first of all, that 17 is one possibility for it. Okay, well, if 17 is one possibility for it, and if I put 17 in there and get the perpendicular distance from there to there, I should get 7 out. Okay, now I'm going to do it where I don't know what 17, and that way I can solve for both 17 and the other possibility at the same time. You know, it just makes sense to do that. So we've got A, we've got B, we've got C, we've got X, and we've got Y, and we've got the answer. Let's put them all together. We do our usual. Okay, 3 times 10, and we've got 4 times minus 3, and then we've got minus D. Or is it plus D? I can't remember. It's plus D. Plus D. And we've got absolute value all over square root 3 squared plus 4 squared, which is going to be 5. You already know that. And that's going to be equal to 7. So this is a nice easy one. So we've got 30 minus 12 plus D over 5 is equal to 7. Okay. that has to be 35, you know, one possibility, but let's work it out anyway. What's that what we got going on here? We've got 18 plus d absolute value equal to 35. Okay, so what are the two possibilities? Well, 18 plus 17 gives you 35. That's one possibility if it's positive. The other possibility is 18 minus 53 is also equal to 35 because it gives you minus 35, but the absolute value minus 35 is 35. So two possibilities are 17 or minus 53 for D. Ooh, that was a nice one. Okay, that one was a tough one. Okay, right. We'll do one more. Okay, one more for the road, as the man says. Okay. Now, question 19. Question 19. This one's just calling to me. I don't know why. It's just calling to me. We'll just see, is there any more juicier ones than that? 40, 15, 54. Oh, okay, 19. I don't know if you can see it there. Find the center and radius of the circle dash. Hence, find the length of a tangent from. Find the length of a tangent from the point 25 to the circle. Ooh, that's an unusual one. The length of a tangent. Okay, let's have a play with this one then. Let's get some numbers down on the page. X squared plus y squared minus 14x minus 2y plus 34 equals 0. So let's get our usual stuff out of here. The center and what's that? Is that? It's 14. Sorry, it's 14x. So the center of that's going to be 7 and 1. And the radius of that is going to be the square root of, what is that going to be? Minus 7 squared and minus 1 squared minus 34. I'm going to get a calculator out for this one. That's 49 plus 1 minus 34. That's 4. Okay, so the radius is 4. So we've got some information straight away on this fella. Okay, so hence find the length of the tangent from the point to do. Okay, I'm just trying to visualize this. Hence find the length of the tangent. I'm going to try and visualize this because it'll help me. And again, you know, when you see yourself in this situation, a quick bit of visualization. So you've got a circle of radius 4. So I'm going to go 1, 2, 3, 4, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3. Now we go to 7 and 1, 4, 5, 6. 7 and 1 is about there. There's the center of it. Okay, so let me just draw this very quickly. Now this is in no way, in any sense of this universe, is this in any way accurate. But what it is, it just gives you an idea. Gives you some idea of where these things are going to be. So with some circle out here on this kind of stuck between the first and the fourth quadrants. Okay, there's the center of it, which is 7, 1. Okay, now it has a radius of 4. We know that. So what's that telling us really? Nothing much, but they do tell you that there's a tangent from the point 25. 25 is going to be up here a bit. So the tangent's up. So it's there and 25. Okay, so I'm just trying to visualize where we're going with this. I'm thinking of Pythagoras on this one. Let me think. Yeah, so this is what I'm thinking. They want this distance here. Okay, so this is 2, 5. it touches at a tangent. So what I'm thinking is when you draw it, you see what I'm kind of getting at here. Okay, you know, it's going to be a right angle. We can get that distance, we can get the hypotenuse's distance, and then we can work out this third side from the point. It's very badly phrased, but I think that's what they want us to get at. So let's go with this, and we'll see, does it come out as a nice number? I hope it goes out as a nice number. Okay, so what are we looking for? We need the hypotenuse, the longest side. So that's going to be x2 minus x1 to be squared. So that's 5 squared plus 1 minus 5, 4 squared. 5 squared plus 4 squared, that's 25 and 16. That's root 41. Okay. Then we need this one. I don't know if we can get this one. Well, we know what this is. It's the radius, isn't it? It's 4. So let's try and think. This squared is equal to this squared minus this squared. Okay, so in terms of Pythagoras, okay, the square and a hypotenuse is equal to sum of the square on the other two sides. So root 41 squared minus 4 squared is give me tangent squared. Okay, so tangent is equal to the square root of root 41 squared minus 4 squared. Oh, please be this. Yeah, it is. I can see it straight away. It's 25, which is 5. So the tangent has a length of, I'll just double check it, root square root of 41. Sorry. Squared minus 4 squared. 5. Boom. Now, is that epic or what? Okay. There you go, lads, and hope you enjoy.